right, thank you everyone. So, probably like most of you, a few weeks ago I was taking some time off work for the holidays. And I decided that would be a good time to do some projects around the house. And one of the projects that I found myself doing involved some electrical work. And while this might sound like a little dicey because I'm a security guy, not an electrician, I was pleased with how straightforward all this is. You can go down to your local home improvement store, you buy these pieces from different companies, they all just kind of fit together. You follow a few basic rules and you can have a safe installation. And it's really fantastic, and it got me wondering, how did the electric industry get to that place, right? Because it probably wasn't like that on day one. And so I was doing some reading about this, and it turns out that no, it wasn't always like this. If you go all the way back to some of the earlier days, you can find a lot of interesting stories about the World's Fair, which took place in Chicago back in the 1880s. And at this fair, one of the big highlights was that they were going to have electricity. They were going to have lights. And so you could come and you could see like this lit up area, and you could see just this spectacle of lights. And before they had the World's Fair, they needed someone that could do this for them. So they put out for bids, and they said, who can light up our streets for us, right? And at the time, there were two big competing bids. One was from General Electric, and Edison was with General Electric, and he was advocating for DC current. And then there was another bid from Westinghouse, and that was working with Tesla, and he was advocating for AC current. And turns out the AC current bid was way, way cheaper. And there was all sorts of debate about what's safer and what's the right way to go. Well, the AC bid basically won, and the rest is kind of history. From there, record numbers of people came to the show. They saw this, they kind of took the ideas back, they thought this is great, and electricity started to take off. Now, it wasn't all that long before problems started to arise, because as you might imagine, people would deploy electricity in one location and then put it in another spot, and before you know it, you have to interconnect them. But if you didn't have any standards, you had problems. There was big problems. People were getting electrocuted, people were dying, systems were not particularly efficient, and it was kind of a scary time. And so eventually, what we now have is the National Electric Code. That actually started around the late 1880s in response to all of this. And it's evolved over the years, and now it's a big fat book that you can go buy, and it has all these rules that are basically a combination of best practices learned from over the years. A lot of those learned through failures, and then figuring out what do we need to do so that we don't have that failure again, and the whole industry responds. And then some of the learnings were also, of course, evolution of technology, things just changing over the years. And here we are, a little over a century later, and things are still improving. So this graph shows electrocution deaths on construction sites in the US, dating from 2002 to 2015. And ideally, this number would be 0, but obviously it's not. What we do have, though, is a downward trend, okay, except for a little blip at the end, and hopefully maybe that curves down again. What's notable here is that we're continuing to improve, right? This industry is finding ways to be safer. How do you identify a hot wire? How do you wear the right safety equipment? And how do you proceed? It turns out this is how engineering works in general, right? So people see failures, they learn from those failures, and then they fix the problems so that the industry as a whole doesn't repeat those failures, right? And so if you're interested, there's some really interesting reading out there about all this. And what you'll see as you start to get into this is some of the failures are technical, some of the failures are human, but they all produce learnings. And one of the really interesting tenets of engineering is that you evolve through those learnings. And so I got thinking, well, how does this apply to computing? Now, we can debate all day if computing is engineering or not, but at the end of the day, computing is arguably more complex, right? We're not dealing with the physical properties of steel. We're dealing with software, which can be hugely complex, and it can have all sorts of problems, as we all know. So I thought it would be interesting to look at a well-studied case of a spectacular failure in the computing world. But to understand what's going on in this particular case, we have to take ourselves through a little bit of a time warp back to 1985. And I'm kind of curious, how many people in this room were like present in 1985, were there and remember it? All right, so we actually have more hands than I was expecting, so that's good. It makes me feel a little better. All right, so 1985, for those that may not remember it or just need a refresher, Windows 1.0 came out. There was this thing called New Coke. It didn't take off. You can Google it. The very first .com domain name was registered. And perhaps most notably, Calvin and Hobbes started. So it was a good time. It was also a time that the system called the Theric 25 was released. So this is a system that was a software-controlled radiotherapy machine. So you would go to the hospital, let's say you had cancer, and you needed radiotherapy. This machine would apply the right amount of radiation to the right location to basically burn out a cancerous tumor or something like that from someone's body. And it saved many, many lives over the years. It also had a few spectacular failures. 4 people died, 2 people were very, very seriously injured. And what was interesting about those incidents is that each of the times that it happened, that there was a problem, the operators got back in touch with the manufacturer and said, I think there's a problem. And the manufacturer said, no, this system is solid. This is like state-of-the-art software. We've tested it. We can't reproduce your failure. It's not our machine. That's the problem. And so everything continued, and then someone else reports a failure, and once again, rinse and repeat. Ultimately, what was new about this machine is it was the first time that it was software controlled, but there weren't any hardware interlocks to actually provide safeguards for what the software did, or in some cases didn't do. So before this, if the software messed up and tried to maybe turn the radiation beam in the wrong direction or put out too much energy, the hardware interlocks would blow a fuse and the whole system would just stop working and no one would get hurt. But they decided that it was worth taking those out because it was extra money and it wasn't necessary because the software was tested and it was all correct. All right, well, this system, to give you a little more flavor, it was programmed on a PDP-11. It was programmed in assembly. It was actually a relatively complex system. And so if you go and start reading some of these case studies, a lot of people will pull out the fact that it was done in assembly as, maybe that was one of the learnings, that maybe you shouldn't do a super complex system in assembly. There's some interesting debates as to whether or not that's the case. I kind of fall on the side that yeah, I think that's probably true. You shouldn't do that. But there were all sorts of problems. It wasn't just the assembly. Documentation was lacking. And we're talking documentation from both sides of the equation here. So the developer docs, the system design, all the things that you look for when you go to do a security audit, yeah, they didn't really deal with that because it was a single engineer that built the system and it was all in his head, so it was all good. There was also not really any good operator documentation. So people that use the system would get errors popping up all the time, and they just, error 25, I don't know what that is, click through, right? We've been there, we've seen that happen today. Hopefully less on safety critical systems, but it's a thing that still happens. Excuse me. Okay, insufficient testing. So this system, they used software components from older systems, and then they just reused them here, and they said, well, it worked before, we're gonna test the component, it works again, but they didn't test the holistic system. And so, so that created some problems. Can I get some water? Thanks. Before I lose my voice here. Let's see, we talked about the error messages, the fault tolerance, the redundancy, and the systemic failures. So while I wait for some water here, there was a lot of learnings. I'll let you check this out real quick, and then I'll come right back. Okay. All right, they're getting my water. I'll talk the best I can in the interim. I apologize. All right, so what did we learn? Oh, thank you so much. The poisoned water. All right, thank you. Ah, good. Water from all angles. All right, so lots of learnings. Obviously, it's good to test things. Software quality assurance must be designed from the beginning of the system. I mean, does this sound new? Is this stuff that yeah. Do we still see these problems today? That's the interesting thing. So a couple years ago, someone wrote a really interesting retrospective on this. It said 30 years later, how has the industry evolved? Are we doing things better? The long and the short of it was, no, we haven't really done all that much better. And I think that's quite possibly true. I think we have made some improvements when it comes to safety critical systems, but if you were to apply these learnings to computing at large, I think it's very true. Apologize. All right. However, a lot of the retrospectives only look at the technical side of things, and I think there's a really interesting question to ask, which is what would have happened if this failure never occurred? That gets you much broader, right? How did the world change because of this? And one interesting thing that happened is a new law passed around 1990 that basically allowed the FDA to collect information about failures of medical devices. And it was required reporting. So before that, these failures would happen and people wouldn't report them. And of course, you could never do a recall. It also gave the FDA the authority to issue a mandatory recall on these devices. All right, so while the software industry may have continued to build systems in the same old way, we now had policy that would ideally help us out a little bit. And I apologize, my voice is not sticking with us. All right, so let's turn the lens on security for a moment. That's what we're all here for today. Surely in the security industry, we do this really well, right? We evolve, we learn from our failures. A few people are kind of smiling and laughing, so stay tuned. There are some good stories at the end here. Okay, so I think where I'd like to start with security is to take us all the way back into the 70s. Bear with me for a moment. We'll kind of fast forward relatively quickly. But back in the 70s, a lot of the security work was happening through the US government and really the military. And what they were interested in doing is building a multi-level secure system. So think a system where you can have top secret information and secret information on the same computer and have confidence that it's going to work out okay in the end. So there was a big interest in this. However, there's a report that was written saying, actually, that's probably not feasible to accomplish. But people pushed on and said, you know what, we really, really, really want this. In fact, we even need this. And so we're going to try to make this happen. At first, the way that we tried to make it happen was by giving design specs to private industry and saying, can you build this system to spec under contract, and then we'll have ourselves a secure system. And that didn't always work. So they moved on to this idea of the rainbow books, which actually, as I came up and was learning computer security, there's a lot that I really like about the rainbow books, and especially the orange book, which described how you can evaluate a system for security. And it had different levels, so you might have heard of like C2, C1, all the way up. The idea here was that they give a little carrot. They could evaluate some of these systems that the private industry created, and then that would incentivize people to start to create more and more secure systems. And over time, the government would just have this whole menu of options to choose from that could do multi-level security. Well, for those that might have followed this story before, it didn't quite turn out that way. In fact, there was a lot of back and forth between the evaluators that were using the Orange Book to evaluate systems and the people that created the systems, because it turns out that the description of what was required for each level of security was kind of too general, right? It was not very specific, and so it left a lot open to interpretation. And so the evaluators would interpret it more strictly, the implementers would interpret it more loosely, everyone's kind of upset with each other, and it really didn't create this really warm, fuzzy, and secure environment. Eventually, this was US-centric, so eventually it's kind of moved on to be a little more international through an effort that's called Common Criteria. That actually basically lives on today. However, around, say, 2000 or so, there's this whole security research community that started to be a little more vibrant. They were hacking into systems and all this kind of stuff. Maybe some of you have heard of them. So what happened was people started hacking into these kinds of systems and realized that the ones that were evaluated to very top levels weren't actually all that more secure than all the rest of the systems out there. And so it had a lot of people scratching their heads, well, we're doing all this work, what's the value? So there is some value here. It provides some assurance, but I think what they realized is they got a little out of their depth, and the systems were too complex and too hard to review. And so they've scaled some of this back, and they typically review slightly simpler systems now. That's a very short summary of a very long period of history, so I apologize if I glazed over something there. But I think there's an interesting quote here. So Butler Lamson, of course, Turing Award winner, he's seen the industry for many, many years. In 2005, he gave a keynote at Usenix Security, and he's basically saying security is a pain. It's a nuisance, and until we fix that problem, the world's not going to get more secure. Now, does that sound like a message that someone's heard before? Like, we hear this all the time, right? And the problem is that this was the sentiment in 2005, and last I checked, oh yeah, that's a long time ago. So we haven't really responded to that, and that's something we need to be thinking about. So things continue to evolve. If you look at the security threats, we go from a world where back in 2002, Microsoft had their big security push to kind of revamp the whole company and get better in security. We see things like spear phishing attacks starting to happen in the late noughts. We see things like Stuxnet and Google being attacked through the Aurora, Project Aurora stuff in about 2010. And then, all the way up to present day where we're seeing things like DDoS attacks, stolen credentials, and it's just like things aren't getting better. And so what are we to do? Well, if I look at the Verizon breach report, we can see like what are the big things here. And DDoS is a huge cause of security incidents. So DDoS is kind of interesting to me because if you look at the amount of bandwidth that's available, like this is the bandwidth for the biggest DDoS attacks year over year. It's growing just by a little. And that's a problem, but it's interesting because this isn't just DDoS. Right, this is a sign of a much bigger problem because this bandwidth comes from building huge botnets, a huge number of compromised machines. So how is it that we're able to have people compromising a huge fraction of the internet to create this kind of bandwidth? That's just a massive systemic security problem, right? The fact that this can even get there. All right, so if we look at the actual breaches, we see stolen credentials, RAM scrapers, a piece of malware, various phishing attacks and stuff like this. That probably rings true to most of us. And in fact, if we look at things like data breaches and records exposed, maybe there's a little bit more hope in this graph. So the number of data breaches is certainly going in the wrong direction. The number of records exposed is the blue line at the bottom there. And it's kind of spotty, but it certainly isn't spiking the way that the data breaches is. So I find this a little intriguing. I actually don't have a great answer for why those two things are deviating. Maybe that is a sign of success, and if someone's aware of that, please tell me because it'll make me feel good. So anyway, just between you and I, let's think about how we as a security industry are doing. So let's grade ourselves a little bit. Now it's just between you and I, so we can kind of keep this very candid, very fair. I think we are failing extremely well. All right, so I'm going to give us an A+ for failure, and I don't feel like I need to spend a whole lot of time on how do we fail better. We're doing that very well. Congrats. How do we learn from the failures? I'm going to give us like a C. So I think we do all right. I think a lot of people are getting into this, do a retrospective, kind of learn from that. The reason why I don't go higher, though, is I would love to see us doing more learning across the entire industry. Right? So how many times have you seen a retrospective where we have like 20 companies in the room? It kind of doesn't happen, right? So if we aren't learning as an industry, then how can we move security as an industry forward together? So if we're all working our little stovepipes, we're just going to advance our stovepipes, and that maybe isn't so great. And so fixing, I'm really not very optimistic on our fixes right now. And hopefully no one comes up and really is upset at me for this, but I'm going to go ahead and fail us on the fix. Because honestly, if we are seeing the same kinds of problems now that we were seeing 10, 20, 30, 40 years ago, maybe it's time for a little bit of a wake-up call. Okay. So what is the path to success? I can't just come up here and give us an F and then walk off the stage. That would be mad. I will take a sip of water, though, as we ponder this a little bit. All right. So it'd be really cool if the answer was get really technical, solve all these problems, like have a cool new whiz-bang solution that answers all of the security vulnerabilities we're having. But I actually think the number one thing we need to do is talk. And for those that isn't your foremost skill, maybe it's a good thing to work on, because I think that's something our industry needs more of. And that's why it is actually great that we have venues like this where we can come talk. But it's not just, hey, what'd you do last weekend? Tell me about that project you did the electricity in your house on. It's like digging into the security problems that we're seeing together, collectively. Understanding what are the common themes and how do we start to move all this forward together. That's the kind of talk that I want to see more of. And as we do that, I think we can start to identify patterns. Now, I don't know if we have anyone in the room that sews. I've grown up with sewing all around me my entire life. And there's an interesting thing about sewing patterns. You can buy patterns from a single company or maybe from the same parent company, and they're all going to look kind of the same, and you learn how to do one of those, and the others from that company are about the same. Then you go buy a pattern from like some new little boutique sewing firm, and it's totally different, right? And you're going to have to like relearn how to use the pattern all over again. And that is kind of where we're at with security, frankly. Security patterns, if we, to the extent that we have them, and I think we do, I'll get into this, they are very specific to one situation, right? So I could put out a security pattern and say, oh, this is the pattern because this is what we do at Netflix. And everyone else in the room says, well, that doesn't work for our network. That doesn't help me. So what we really need to do is think about how do we advance these patterns of how to do security right into a way that actually helps the whole industry. And then if we find problems in the patterns, then we fix them and the whole industry gets better, right? Not just the one place where this one little pattern is used. So it turns out security patterns are a thing, or at least at some point in the history of our discipline, they were a thing. I don't feel like there's been quite as much chatter of them over the past maybe half dozen years. But you can go to websites like this one, and you can find lists of security patterns. You can go to Microsoft actually has some really nice patterns on their Azure website. You can go check those out. I think this is great. I also put this diagram down here on the bottom because this is like a visual of the patterns on that website. And you'll quickly realize these are patterns that only a security practitioner can love, right? These are for us. And that's okay, but if we want to actually improve the security of the world, then we need to take an additional step and say, how do we take these patterns and package them up in a way that's easy for the rest of the world to use, okay? Because software engineers that we're working with, they have enough on their minds. If we provide them this complex puzzle and hope that maybe they assemble it correctly, we're probably not actually solving the problem. And what do I mean by easy? Well, a lot of people will say things like, can you just put TLS on that endpoint? It will be really, really better. And maybe you're right. Maybe TLS is what's needed for a particular setup. And then I've even heard people go so far as to say, yeah, you throw a cert and a key on there and you're good. Okay. Well, what is actually involved in doing that? Particularly, maybe you're at a startup and you don't have all these established infrastructures. Well, all of a sudden, it's not just throwing a certain key on there. You have to say, well, what's the PKI look like? Where's the certificate authority live? How do I protect those keys? Do I have to have some sort of backup regime? What's the security situation for that? Oh, and by the way, how do I even configure the TLS setup in the first place? So I've got all of these questions that I have to ask before I can end up with a reasonable answer. So it's not just put TLS on there. It's like bring an expert in the room to turn on this thing that's been around for decades that should solve your problem. But that's kind of a sorry state of affairs. So one of the things that we've done at Netflix to help simplify things a little bit is we said, you know what, we don't want everyone at the company to have to deal with all of this. Instead, just do that. So there's a configuration file. You can set one parameter in it. All of that happens correctly for you. And not only that, you also get authentication and some other fun things. And you're like kind of future-proofed, because if you redeploy your software in the future and we decided, oh, you shouldn't be using TLS 1.0 anymore, you should really be on 1.3, all of that can just evolve automatically. That's winning. But that's winning for a part of the ecosystem, right? We have to remember, think back to like the Theric 25 situation. You can't just evaluate one narrow chunk and say we're good. You got to look at the whole system. And as you step back, you're going to see different things. So to put it all together, if I were to kind of highlight what we need to do better for failing, it's nothing at all. We're failing just great. So if I highlight what we need to do better for learning, we need to talk. Okay, we need to align on how we're thinking about our systems so that we have something common that we can talk about, right? If I'm talking about how to do authentication to someone at another company, hopefully we're doing it close enough that we can learn from each other and evolve those things together. We need to share our lessons, find the trends, and ultimately connect all those to the risk and impact that they have, so we're actually spending our time on the right things. And finally, for fixing better, we need to think about patterns. We need to think about how does all this come together in a usable way so that the industry can use our things and advance together and ultimately start to get rid of these problems that have been plaguing us for a very long time. All right. So as I put together this talk, I realized that if I had ended it right there, it might be a little bit of a downer because I'm kind of beating us up. And sometimes that's what's needed, but I thought it would be useful to at least pull out a few stories of some places that I think are doing this right. And so this isn't like an endorsement from me or an endorsement from Netflix or anything like that. This is just places where I think people are working in the right direction. And I'm seeing interesting signs of success. So the first one that I'll highlight is SPIFFE. How many people are familiar with the SPIFFE efforts? Okay. Not a lot of hands. So go Google it or go to spiffe.io, spelled like that. It's kind of interesting because basically what they're doing is they're saying app-to-app identity and authentication has gotten very stovepiped at all these different companies. Everyone that they're doing it in the cloud, but they're all doing it their own way. And it means we can't interoperate, we can't evolve the industry forward. So let's find a common way to express identities, find a common way to do the authentication and all of this, and finally move forward on some of these things. Very interesting. There's some reference software. There's things like the Envoy proxy, which is starting to use this, and some other software projects getting involved. So very interesting work. It's kind of early days, but I'm seeing it leaning towards the directions that are what I'm talking about, and I thought it would be worth throwing it out there. So what about something from a little further back? Software auto-updating. Who remembers web browsers before software auto-updating? Right? It was quite the world. And the problem is that in your web browser, a software vulnerability can be a really bad day. And so this was genius. Now, these graphs are from a long time ago. We're looking at 2012 to 2013. On the left, we've got Chrome, which had auto updates installed at that point in time. And you can see every new version comes out in this really steep adoption curve. It's like, boom, almost instantly, everyone's on it, right? And then on the right, you've got Internet Explorer. At that time, did not have auto updates. You see new versions are released and adoption just kind of wanes, right? Why don't we do auto updating across all of our stuff, by the way, right? I mean, we have a lot of software that we don't do this on today. But hey, the win is we do it in some places, which is great. All right, and the final one that I really want to highlight for today is this. If you look at the top 1 million websites out there and you look at how many of them are using HTTPS, we crossed the 50% mark this year, which is super cool. And this didn't just happen, right? This is a combination of work from tons of people, like lots of work going on at Google, lots of work going on at Let's Encrypt, lots of work going on sites like the SSL Lab site that helps people configure their sites better and more secure. It's just so many things that came together towards a common goal, and the industry is getting there. And now that we're past 50%, who knows? Maybe we see that curve tick up even faster and get even higher. So, on that note, I would say take this home with you. Let's work on securing the whole system, not just a little slice of it, and let's secure it in a way that works for everyone. And I think the way that we get there is by figuring out how do we fail together, how do we learn together, and ultimately, how do we fix the problems together. Thank you.
So if you guys have any questions for Bryan, just let us know.
Are you at liberty to give some specific examples of something that Netflix was failing at and not necessarily learning from its mistakes, and then something that where you were able to turn that around? Or have your lawyers at Netflix advised against that?
Yeah, I'm trying to think of a good failure. Actually, I mean, Scott's working on a whole thing of failures. Is there anything that we can feel comfortable talking about right now, or is it?
Yeah, I would go share a very short accolade.
Just because he's been working on an internal presentation on failures, which is
Yeah,
like so on point. So I just thought
We ventured into the automated vulnerability scanning at scale in a couple different factors, and in each step of the way, we failed pretty epically. In one of the cases, we spent about 6 to 9 months operationalizing a scanner that never found a vulnerability. And part of what we learned along the way was actually, and this was the learnings that has ultimately resulted in sort of the fixes. We didn't have great scoping when we went into the project. I think our goals weren't well aligned with reality, and we were actually able to take a lot of that and sort of refocus our efforts, and not on vulnerability identification, but in other areas that we do in AppSec that would be easier for us to solve. But there was a really long period of time where we failed. And another thing that we learned too along the way was we needed to set objectives and success criteria, like the kinds of things to measure that we're spending our time right way earlier in the process, because it was like 6 months in, we're like, should we pull the plug now, or should we have pulled it about 3 weeks in when we realized this thing wasn't going to work? So.
yeah. I'm just getting the mic to the right spot here.
So thank you for the talk, and thank you for running a team that socializes as much of the knowledge as is produced within Netflix out to the open world as they can. I can't count how many tools from Netflix me and my team use at the firm where I currently work. So kind of talking on the idea of just like socializing knowledge and standards and what have you, one thought that crossed my mind, I have no idea if this is the appropriate way to go, would be to standardize on certain configurations and then update the configurations. Like as an example, if we've got like multiple libraries implementing TLS, then standardizing and deploying configurations as easily as possible via, let's say, one standards body might be one approach to bring security up to like a common spec, the way you might see with, let's say, making electricity safe, if we're building on that analogy. Are there any, one, does that pattern sound appropriate to you or applicable in any wide array of security concerns? And two, if so, do you see any particular roadblocks that might need to be surmounted in order to make such an environment happen?
Yeah, so you're on point as far as I'm concerned. I mean, what this ultimately comes down to is standardization efforts, and I kind of resisted using that word a bit in the presentation because I think people bristle at it, and maybe rightly so. It takes a long time. You got to get people to agree. You actually have to understand someone else's viewpoint. It's tough work, but it's the important work, right? And if you look at a lot of the computing systems that we use, there are a lot of standards, right? I mean, that's how we can do networking at all. That's how TLS works at all. But there's a lot of knobs, right? So as we work ourselves up the stack, we started to standardize less. And I think now that we're seeing more, say, cloud native deployments and things like this, there's opportunities to go higher on the stack and standardize higher and then start to get those wins. So absolutely.
Having worked on a lot of standards, they're a painful thing because everybody has different medians of what they consider success. And I've noticed over the last few years that the need to get agile DevOps is so important that I wonder how much of the management technique is associated to failures in security. I mean, certainly you can have a secure aircraft system if you have requirements, test, and verification. Very hard to do if you're doing a web page and you have your primary goal is how quickly you get that out into the field.
Yeah, I mean, it's different industries are going to have different needs, right? So if you're launching the Mars rover and once that system launches, you can't really change it too much, then it's going to go through pretty rigorous testing. It's going to have probably more like a waterfall model and all of that. But the sort of risk and benefit equation may not suggest that that is the right model for everything, right? And so there's definitely times, in my opinion, when moving quickly is the appropriate thing for the industry or for the business. But we don't have to, say, throw our hands up in the air and say, oh, well, therefore security can't happen. I think we need to just figure out, well, what does that mean? Can we get the appropriate level of security in that system through that development methodology? And if the answer is for your business, no, then maybe that's the wrong development methodology for your business. But I think for a lot of businesses, it's yes, because security needs are different. And so we just rethink how we do it, right? You get into the CI/CD pipeline, you insert sort of lightweight controls. And one of the beautiful things about the agile system, or anyone that's moving super fast and constantly redeploying, is that if there is a security bug introduced, you can fix it just as fast, right? And so that's counter to, say, like a more traditional enterprise software company where you're on the twice a year train station release kind of schedule, and if you happen to get a bad thing out the door, you're going to wait a long time to fix it. And so there's pros and cons, and I think you just have to find the right one that's appropriate for your business. Yeah. I see a hand right over here.
How do you feel about externalized costs, the tragedy of the commons, and how that is an issue with security, IoT, smaller companies, et cetera?
What do you mean by externalized costs, just so I'm on the same page here?
Well, the failure of a device that is very inexpensive, or a website that's maintained by a small company but has access to a lot of user data. These things have a lot of external costs that company may not pay. And so you have a very wide variety of these smaller, cheaper devices, companies, pieces of software where that company may not even be around for very long, yet their devices live on, or their software has wide-ranging effects, et cetera. And so, how do you incentivize changes to this broader ecosystem where little things that companies do have much broader effects?
Sure. What I'm about to say might feel overly optimistic, so you feel free to let me know. But I actually think that if you look across the industry, if you go to this conference, you're going to find a lot of people that are investing time at their respective companies doing effectively the same thing, right? Like, how many companies have software engineers that are working with TLS to do, authentication or some sort of OWASP system or something like that, and they're building it out? And then basically fighting the same challenges day in and day out. And the problem is that if you're a small IoT company, you're having the same burdens and all this kind of stuff. My hope is that if we can start to advance the whole industry forward and work together, maybe it becomes easier, right? We always talk about this shortage of security personnel across the industry. Maybe we wouldn't have such a shortage if we didn't have to have every company hire the same skill set, but instead we could work together a little more, right? And then as we work together and we kind of raise the bar across how like a TLS stack gets deployed, and there's just like, here's how you do it and it's the right way, then that little IoT company can consume that and not have to have a TLS expert on staff, and we end up with actually better security in those products just as a byproduct. So I would love for us to get there. Maybe it's a little rosy colored glasses, but I do think some of that is possible.
Okay, we'd like to thank Bryan again. Have another round of applause.
Thank you.
Thank you.